welcome back to the channel where we make coding and math super fun and easy to understand. Today we are diving into a really interesting question: how to calculate the distance between 2 points on a Cartesian plane. Not only we will explain the logic behind it, but I am also going to show you multiple approaches to solving it, along with the code in Java. Sounds awesome, right? Okay, come, let's get started. Okay, so here the problem. You are given a coordination of 2 points and you need to find the distance between them. For example, if one point is at 0, 0 and other point is at 2 minus 2, how far apart are they? The answer needs to be rounded up to the nearest whole number. Sounds simple, right? Okay, let's break it down. We are going to use something called the distance formula to calculate the distance between these 2 points. If you have never seen it before, don't worry. This formula is super straightforward. Okay, let's see the formula. Distance formula, whole root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We are going to use something called this distance formula to calculate the distance between 2 points. If you have never seen it before, don't worry, the formula is super straightforward. This might look a little intimidating, but it's really just telling us to find the difference between the x coordinate and the y coordinate and square them, add them together and then take the square root, and don't forget we'll round it the final result to the nearest integer. Let's see how it works in Java. First, we will calculate the distance using the formula and then we will round up the result. Here's how the code looks. Okay, let's code. Calculate the difference between coordinates. So for that, I put dx equal to x2 minus x1 into dy equal to y2 minus y1. Use the distance formula here. I give double variable name as distance for dist. I use math.square. Math.square root for identify the square root of the coordinates. Dx into dx plus dy into dy. Okay. Next, round the result. For that, return integer. I use math.round or math.scale. What is the result? Dist. Okay. In this code, we first calculate the difference between dx and dy for the x and y coordinates. Then we use math.square root function to find the square root, and finally we round up using math.round. Pretty easy, right? Now let's check out some other approaches. First, let's see the test case passed. Okay. Okay, here's the test case passed. Now the second, we have to see the second approach. What if we want, what if we don't want to use floating point number or square roots until the very end? We can use something called integer squared distance. This approach calculates the distance squared and at the last moment we take the square root and round it. For it we have to change the simple one here. For this line we have to change int dist squared equal to dx into dx plus dy into dy. Then we calculate the square root and round up. Here we calculate the square root and round up. For return int, here I use math.sail. Math.square root to find the square root of dist squared. This is the other approach. This is especially useful when you are trying to avoid precision issue caused by floating point numbers and still it gives you the exact same result in the end. Okay. Let's say you need super precision when dealing with the large number of decimal points. In Java, you can use big decimal to handle rounding and precision which more accurately. Here's how would you do it. Okay. For this, calculate the distance. Using math.square root. SQRT. Okay. I here put as the double dist. Okay. Here I use big decimal. Okay. How I use big decimal means big decimal. I give the name as BD equal to new big decimal of dist. Semicolon. BD equal to BD dot set scale. 0, rounding mode dot sailing. Rounding mode dot sailing. Then return BD dot int value. Okay. This is the other approach. This approach is super useful when you want to control precision at a deeper level. You rarely need this much precision for basic problems, but it's great to have when you do. Okay. Other approaches, math and distance. Okay. If a precision isn't a strict requirement and we are okay with approximating the math and distance is a simpler metric that only consider absolute difference in x and y coordinates. It is used in grid-based problems like pathfinding in 2D grids. For this math and distance formula is of x2 minus x1 of plus y2 minus y1. This is the math and distance formula. This is a simpler and faster approach but less accurate for Euclidean principle. Let's see how to code it. Here I put public static int oh my god, sorry, MEMHATTN. For that here math and distance calculation, how to calculate means return math.abs x2 minus x1 math.abs of x2 minus x1 plus math.abs of plus math.abs y2 minus y1. We take the absolute difference in the x and y coordinates and sum them up. This approximation works well when the points are aligned more closely along the axis, but it is less accurate for diagonal decision. So that's it. We have explored a few different ways to calculate the distance between 2 points on a Cartesian plane. From the classic distance formula to using big decimal for precision and even taking shortcut with math on distance. Whether you are solving math problems or programming, these methods will help you to get the right answer every time. If you found this video helpful, don't forget to like, share and subscribe for more fun and easy coding tutorials. See you next time and keep learning with a smile. Bye.